Good afternoon to you all and greetings from Rome. With this presentation today, I would like to present you our solution to the product recognition in retail data. The aim of this demonstration is to present you a system that we have developed here in HQ, which automatically recognizes and categorizes the products by their descriptions and updates the article master data catalog. But before we continue, let me first list the challenges that we are facing and which relate to the product recognition itself. First challenge is so-called data variability. We source information from different retailers who each use their own product catalog. Hence, for the same product, we may receive as many descriptions as their retailer selling it. Some descriptions will be in Arabic, some in English, some with spelling mistakes in dialect with abbreviations, etc. Second challenge is grouping of the same products. The retailer might or might not record the barcode of the product that is being sold. However, even if the barcode is recorded, the same product might have different barcodes, for example, due to country or date of packaging. So the question is, how do we know which products are the same? And of course, the third challenge is scalability. How to ensure that with growing operations, we can still assure the high quality of the information in a timely manner. Before describing the whole process, we must first define what is our minimal set of properties that uniquely characterize the product. With respect to our needs and analysis, we defined that our minimal set consists of the following 5 characteristics: brand, commodity type, pieces, packaging units, quantity, and promotion. So what does this mean in practice? We have, for example, Nido powder milk in a bag of 900 grams. Then we have Picon, 6 pieces of cheese triangles, making 125 grams, but the product is on offer, minus 50%. Then Maggi, 24 chicken bouillon cubes, together they weigh 325 grams, and you have 3 of those packages. Deroni, Egyptian rice, 900 grams in a bag or a box, actually 2 of them, and you get 900 grams of flour extra. Then you have non-barcoded products, potatoes of 1 kilo and bananas sold by weight. Let's have a deeper look in one specific product, that is Deroni, Egyptian rice. This barcoded product has been sold in Lebanon in roughly 30 shops during the last 3 months. So here I'm displaying just few descriptions how retailers describe the SKU in their own product catalog. When we look at it with our human eyes, we can immediately spot the patterns, even if we don't understand the language. But how to teach a computer to do this? This was actually our challenge. As we can see here, we have identified from the descriptions, in most cases, what is the brand, what is the commodity, what is the quantity, what is the packaging, and even what is the offer. Because once we have those characteristics extracted, and we know that they describe the same product because of the common barcode, we can easily select the best ones, that are the ones that are whether the most descriptive or appear the most times. The idea behind the algorithm is that we have created so-called dictionaries. First step was that we define standardized entity property values. That is for commodity type, rice, powder milk, tuna, in vegetable oil, etc. And the second step was then creation of the dictionaries. In practice, that means that we parse a description, check if certain keywords appear in it, and we return the standardized commodity description. Here on the right, I'm showing an example of the sardines. If you have a look, for example, at row 13, so if all those 3 keywords appear in the description, then we can deduce that this commodity is sardines in vegetable oil hot. In a similar manner, we can then extract also other entity property values, that is brand name, quantity, offer, etc. Here I'm just showing you some more examples to show you the capabilities but also the shortcomings of the algorithm. I'm displaying some random product descriptions that, let's say, we would like to recognize which products they actually are. So we run an algorithm, it takes only a few seconds, and here we are. We can see that for the sales descriptions, for example, 3, 4, 5, 14, 15, the recognition is very accurate. However, the algorithm failed to recognize Nido powder milk in row 8 and 9, that is here, because there's a space missing between Nido and milk. Or for example, in row 2, we see that the recognition was quite accurate, but we are missing the quantities for the oil, basically for the offer. And the units are actually missing from the original description. So once we're here, once we know all those characteristics of the product, whether they are given by the barcode or by description, we first check if this product with these exact entity property values already exists in our article master data catalog. If so, we just store information that this description or this barcode belongs to that specific SKU. However, if the product does not exist, the algorithm automatically creates a new entry in the article master data and again store the information of description or barcode belonging to this new entry. And then our job is done. Well, almost. As you can see, not all products were recognized, or were recognized only partially. But on the bright side, once the dictionary is expanded with corresponding new mapping, also those descriptions will be successfully categorized. To conclude, let me first start with challenges. Construction of the dictionaries is a manual work, and the best way is that if the person who's constructing them knows the language and has a very high attention to the details, but still the process might be very lengthy and tedious. The second challenge is the time complexity of the algorithm itself. With dictionaries growing, the time required to extract characteristics also grows. Still, we're speaking only of a couple of hours process. About the achievements, with this algorithm, we have achieved quite a progress in identifying products and grouping. In Lebanon, for example, in October 2018, the sale value of categorized sales is 90%, in Syria 67%, in Jordan a bit less, 56%, while in Iraq it is 93%. And for the future, the way to go is to continue exploring the possibility of unsupervised machine learning. This is how we would remove, at least partially, the manual work that is needed to construct the dictionaries, and also the scaling up would be way faster and easier. With this, I would like to conclude my presentation. Thank you very much for your attention, and I wish you all a very nice day.